Have you ever just stood there, staring up at a massive skyscraper or maybe a huge power plant, and just thought, how? I mean, seriously, how do thousands of people with millions of parts all manage to come together and create something so incredibly complex? Well, we're going to get into that because the answer is honestly fascinating.
It really all boils down to this one question. How does a simple idea, a vision that starts as a sketch on a napkin, actually transform into a towering reality of concrete and steel? It feels like it should be magic, right? But it's not. It's a system.
And that system is built on what you could call a secret language. It's a visual language, spoken through construction drawings. And this language isn't static. It grows, it evolves, it gets smarter and more detailed as a project goes from just an idea to a living, breathing structure. And understanding this language, well, that's the key to everything.
So let's follow that journey. Let's trace the life story of a single drawing to see exactly how it manages to conduct this massive, complicated symphony of construction.
You see, a drawing basically goes through 5 major stages in its life. It all begins as a concept, just the spark of an idea. Then it gets detailed enough to become a tender drawing, so companies can bid on the work. Once a winner is chosen, it's finalized as an issued for construction or IFC drawing. From there, it gets transformed into a super detailed shop drawing, the real how-to guide. And finally, its life ends as the as-built, the true story of what actually got built. Each stage has a really critical job to do.
All right, so let's zoom in a bit and look at what's actually happening at each of these stages. The way a drawing transforms from this vague dream into an incredibly detailed plan is, well, it's pretty amazing.
Take a look at this. You can literally watch the drawing grow up. It starts out as a low-detail concept made by the architect for the client. Pretty simple. Then it gets a medium level of detail for the tender phase, so contractors can figure out how much it's going to cost. The IFC drawing gets to a high level of detail, but notice who's making it, the design consultant. But then look at this shift. For the shop and as-built drawings, the detail level jumps to very high, and the author changes. It's now the contractor, the builder who's creating these for the teams on the ground and for the final owner. The whole purpose, the audience, even who's drawing it, it all changes. And that evolution, that handoff from the designer to the builder, brings us to what is maybe the single most critical moment in any mega project. This is where the beautiful dream of the architect meets the cold, hard reality of the builder.
It all comes down to this, the what versus the how. The IFC drawing from the designer, that's the what. It says something like, we need a substation right here and it needs to handle this much power. But the contractor's shop drawing, that's the how. It says, okay, we bought this specific transformer from this vendor, and here is precisely how we are going to install it, using these exact bolts, routing these cables this exact way. It's the leap from theory to practice.
And this is where the real magic happens. During this shop drawing phase, engineers run something called clash detection. Basically, they build the entire project digitally, in 3D, to find all the places where things go wrong. Where the massive air conditioning duct is supposed to go through the exact same space as a critical electrical cable tray. Finding that mistake on a computer screen can save millions of dollars compared to finding it on site when you have 2 tons of steel that won't fit.
And this quote just hits the nail on the head. This stage isn't just about tracing lines or following directions. It's about intense, practical, real-world problem solving. It's about making the architect's vision actually possible to build. This is pure engineering.
So how does it all work? Well, it's kind of like a funnel. You start with the architect's big picture design. Then, the contractor swaps out all the generic placeholders with the actual equipment they've bought. Next, they run that clash detection to find and fix all the interferences. And finally, they create that ultra-specific, step-by-step guide for the installation team. You go from a general idea to a specific, foolproof plan.
Now, of course, we're not just talking about one drawing. A megastructure has hundreds, sometimes thousands of them, and they're all created by a whole team of specialists, each speaking their own unique dialect of this visual language.
Think of it like a body. The architectural drawings, that's the look and feel, the skin. The structural plans are the skeleton, holding it all up. Mechanical is the building's lungs and circulatory system, all the HVAC and piping. Electrical is the nervous system, sending power and data everywhere. And plumbing, well, that's the essential water and drainage. And all of these systems have to weave through each other perfectly, which is exactly why that clash detection step is so absolutely vital.
So once all the problems are solved, the clashes are detected, and the building is finally standing, the drawing's journey is over, right? Well,
Not quite. It has one last, incredibly important job to do.
Because here's the thing, no plan ever survives first contact with reality. And that's especially true in construction. Out on the site, things just happen. A concrete beam ends up a few inches to the left. A buried pipe is discovered that wasn't on any old plans, so a new pipe has to be rerouted. Small changes are constantly being made on the fly.
And that's where the as-built drawing comes in. As all those little changes are made on site, they're marked up on the drawings, usually in red pen. At the very end of the project, all those markups are collected into one final, perfect set of drawings that show what was actually built. It's not the plan anymore, it's the building's official biography, and it is absolutely essential for anyone who ever has to maintain, operate, or even renovate that building decades from now.
So in the end, you have to realize that these drawings are so much more than just lines on a page. They are the legal contract that says what will be built. They are the detailed instruction manual for how to build it. And they become the final official history of what it became. They're basically the soul of the entire project.
Which really just leaves us with one last question to chew on. For more than 100 years, this language has been spoken on paper. But now, as we're moving into this crazy new era of digital twins and fully integrated 3D models, what's the next chapter in the story of the blueprint? What will this secret language look like tomorrow?